this video, we are going to talk about the locus of a complex number. The locus of a complex number indicates all the possible values of z satisfying a given condition. So for example, let's assume that we have this point O, and then we have another point here, let's say P, and then the distance between O and P is represented by R. If we maintain the distance R, and then we change the position of P, and let's say we bring P here, and let's say that point is Q, then we maintain that same radius, and then we change the position of P to, let's say, here. If we keep changing the position of P, at the end of the day, you see that P is going to form a complete circle, and therefore the locus of a single point is a complete circle. PQ is equal to the vector Q minus the vector P. So complex numbers, the locus of complex numbers when plotted on a Cartesian plane behaves like vectors. Now, the locus of a single point is a circle, and then the locus of 2 points is a straight perpendicular line. So it is a straight perpendicular line to the 2 points. And the last is the locus of 3 points is another point. If the locus of a complex number is represented as the modulus of z minus zy cos r, then it means that the locus is a circle with center z1 and then the radius r. So using this understanding, let's sketch the locus of the following complex numbers. The first one is the modulus of z plus 3 equals 1. So what we will do is that we write modulus of z minus 3 equals 1. So if you look at this complex number, you see that the imaginary part is 0. So this is the locus of this. The locus of this complex number is a circle with center minus 3, 0, and then radius r equals 1. So let's sketch it. So this is the Argand diagram. Now let's sketch this complex number on the Argand diagram. So the center is minus 3, 0. So this is minus 3, 0. And we know that it has a radius of 1. And it is a circle. So that means that if we move to the right, that will be 1 unit to the right, 1 unit to the left, then 1 unit downwards, and then 1 unit upwards. So if we connect the points, you see that this is how the circle is going to look like. So this is the graph of this complex number, which is z plus modulus of z plus 3 equals 1. What if we were given modulus of z minus 1 plus 2i equals 2? So let's sketch the locus of this complex number on an Argand diagram. So you write it as z minus into brackets. Here becomes 1, then plus 2i becomes minus 2i. Such that if we multiply by this minus 1, we'll get back our plus 2i equals 2. So this is a circle with center 1 minus 2 and then radius r equals 2. So let's represent this on an Argand diagram. So this is how our Argand diagram will look. So the center of the circle is 1 minus 2. So this is 1 minus 2, it's here. This is the center of the circle. And then the radius is 2 units. So that means that your bottom is 2 units. So 1, 2, that will be on minus 4. Then to your right is 2 units. So 1, 2 is going to be here. at where 3 is. Then to your left is 2 units. So that was going to be at where minus 1 is. Then on top is 2 units. So that is going to be here. So if we connect the points together, we are going to form a circle which looks like this. So this is how the locus of this complex number is represented on an Argand diagram. What if we were given real part of into brackets I times the conjugate of z is equal to 3? How do we represent this on an Argand diagram? So what we'll do is that, remember that z is equal to x plus iy, and then the conjugate of z is equal to x, then you negate the imaginary part minus iy. So the real part becomes re then times I times x minus iy is equal to 3. So let's multiply it. So real part of here becomes I times x becomes ix, then minus I squared y is equal to 3. So it becomes real part of I squared minus I squared is 1. So it becomes y then plus ix equals 3. But then he says that the real part, so the real part is y. So the real part is y equals 3. And therefore, you can see that this is a straight line. So let's represent this on an Argand diagram. So this is how the graph is going to look like. This is the line y equals 3. So the next example is modulus of z plus I equals modulus of z minus I. So we solve this by making this substitution, z equals x plus iy. So this part becomes modulus of x plus iy, then plus I equals modulus of x plus iy and minus I. And this is equal to x modulus of x plus I into bracket y plus 1 equals modulus of x plus I into bracket y minus 1. So we will square the elements inside. So this becomes x squared plus into bracket y plus 1 squared. And that is equal to this sign, which is x squared plus into bracket y minus 1 squared. So this becomes x squared plus, if we expand y plus 1 squared, it's going to give us y squared plus 2y and plus 1 equals x squared then plus y squared minus 2y then plus 1. So you see that plus 1 and plus 1 can cancel out. X squared and x squared can also cancel out, and y squared can also cancel out. So at the end of the day, we have 2y equals minus 2y. Then if you bring this minus 2y to this side, you are going to get 4y equals 0. 4 is not equal to 0, and therefore the only thing that is equal to 0 is y. So this is how this is represented on an Argand diagram. It is y equals 0. So y equals 0 is the real axis. So let's solve this equation. So let's sketch this modulus 2 on an Argand diagram. It is modulus of z plus 2 equals modulus of z minus 5 plus I. So let's use the substitution z equals x plus iy. So this is modulus of x plus iy plus 2 equals modulus of x plus iy minus 5 plus I. So this becomes x plus 2 in one bracket plus iy equals modulus of into bracket x minus 5 then plus I into bracket y plus 1. So let's square it. So x plus 2 squared plus y squared is equal to into bracket x minus 5 squared plus y plus 1 squared. So if you square this, it becomes x squared plus 4x plus 4 plus y squared equals, if you square x minus 5 squared, it becomes x squared then minus 10x plus 25. Then if you square this, if you expand this, it becomes plus y squared plus 2y then plus 1. So x squared and x squared can cancel. Y squared and y squared can also cancel. So let's bring all of this to the right hand side of the equation. So it becomes 2y, then 25 plus 1 is 26. So 26 minus 4 is 22. So plus 22. Then here is minus 10x minus 4x becomes minus 14x is equal to 0. So let's divide through by 2. If you divide through by 2, you get y minus 7x plus 11 is equal to 0. Or in other words, y is equal to 7x minus 11. Now there is so this is the locus of this complex number is a straight line. Now there is an alternative to this question. So the alternative is, this can also be represented as modulus of z minus 2 equals modulus of z minus into bracket 5 minus I. Modulus of z minus 2 is a point that is minus 2 and then 0. So let's say that's point 1. And then the second point, point 2, is modulus of z minus into bracket 5 minus I. It is 5 and then minus 1. So that is point 2. So what we will do is that we'll find the midpoint of point 1 and point 2. And that is equal to, you sum the x values and then you divide by 2. So that is minus 2 plus 5 divided by 2. Then the y-aspect is minus 1 then plus 0 divided by 2. So minus 2 plus 5 is 3 divided by 2. And then minus 1 plus 0 is minus 1 divided by 2 is minus 1 over 2. So the midpoint is 3 over 2 and minus 1 over 2. Then let's find the gradient, which is m. M is equal to, so using this same point, the change in y over change in x. And this is equal to, the change in y is going to be minus 1 minus 0 divided by 5 minus 2. And this is equal to minus 1 over 7. However, the new line will be perpendicular to this point. And since they are perpendicular, the actual gradient, mt, is the inverse, the negative inverse of the first gradient. And that is going to give us 7. Now, we have this point together with the gradient. So, since we know that it is the equation of a straight line, which is given as y equals mx plus c, we can use this equation to find the y-intercept. So using this point, it is minus 1 over 2 is equal to m, which is the gradient 7 times 3 over 2 then plus c. So c is equal to minus 1 over 2. Then 7 times 3 is 21 minus 21 over 2. And this is equal to minus 22 over 2. Therefore, c is equal to minus 11. Therefore, the equation of the line y is equal to m, which is 7x. Then c is minus 11. So you can see that using both methods will still give us the same answer. So let's sketch y equals 7x minus 11 on an argand diagram. So the first thing is to find the x-intercept. So for the x-intercept, y is equal to 0. So x is equal to 11/7, which is equal to 1.6. So we have the point 1.6 and then 0. Then the second thing is to find the x-intercept. Sorry, the y-intercept. And for the y-intercept, x is equal to 0. So y is equal to -11. So we have the point 0 and -11. So having gotten this point, let's sketch. So let's plot the point on the Argand diagram. So we have 1.6 and 0. 1.6 and 0 is less than 2. So it's somewhere here. And then 0 and -11. That one too is somewhere here. So this is the line y equals 7x minus 11. Nonetheless, you see that the actual points are -2 and 0, and then 5 and 0. So what is the locus of the point that describe these complex numbers? So we know that z is equal to x plus iy. This becomes modulus of x plus iy minus 2 equals 3 times modulus of x plus iy minus 10. So this becomes x minus 2 modulus of plus iy equals 3 times modulus of x minus 10 plus iy. So let's square. This becomes x minus 2 squared plus y squared equals 3 times x minus 10 squared plus y squared. So let's expand. This becomes x squared minus 4x plus 4 and plus y squared is equal to 3 times x minus 10 squared is x squared and minus 20x and minus 100 plus y squared. So this is equal to x squared minus 4x plus 4 plus y squared equals 3x squared minus 60x minus 300 then plus 3y squared. If we take everything to the right hand side, the equation becomes 2x squared plus 2y squared and minus 56x and plus 296 equals 0. So if we divide through by 2, it becomes x squared plus y squared minus 28x and plus 148 is equal to 0. So let's complete the squares in this case. So this becomes x squared. Then you find half of minus 28 is minus 14. And if you square minus 14, you will get 196. So here will be x squared minus 28x plus 196 is equal to, you take this to the right hand side. So it becomes minus 148. Then we add 14 squared, and that will be 196. So this can be written as x minus 14 all squared, and this is equal to 48. Sorry, I forgot to add y squared here. So there is y squared here. So let me add the y squared plus y squared. So let me rewrite this as x minus 14 all squared plus y squared equals 48. But we need to express this as r squared, and therefore we need to find the square root of 48. And the square root of 48 is 4 root 3. So this becomes x minus 14 all squared plus y squared is equal to 4 root 3. So this is a circle with center 14 and 0, and then radius 4√3 units. Sketch the locus of z and obtain the Cartesian equation of z. Modulus of z minus 3 plus 2i, all divided by z plus 2 minus 3i equals 1. So this can be written as modulus of z minus 3 plus 2i divided by modulus of z plus 2 minus 3i equals 1. So if you multiply the denominator by both sides, it becomes z minus 3 plus 2i equals modulus of z plus 2 minus 3i. So let's insert z equals x plus iy, and therefore this becomes x plus iy then minus 3 plus 2i equals modulus of x plus iy then plus 2 minus 3i. So continuing from here, it becomes into bracket x then minus 3 plus I into brackets. Here is 1 y plus 2 equals modulus of, here is x plus 2 then plus I then into bracket y minus 3. Therefore, if we square, so here becomes x minus 3 all squared plus y plus 2 all squared equals x plus 2 all squared plus y minus 3 all squared. So this is equal to x squared then minus 6x plus 9 then plus y plus 2 squared is y squared plus 4y plus 4 equals x plus 2 squared is x squared plus 4x plus 4. Then y minus 3 squared is plus y squared minus 6y then plus 9. So at the end of the day, this plus 9 and plus 9 cancels out. Then x squared and x squared also cancels out. Then y squared and y squared also cancels out. So we are left with minus 6y then plus 4y plus 4 and plus 4 also cancels out equals 4x minus 6y. So let's take the x to the right hand side and then the y to the left hand side. So we get 4y plus 6y is equal to 4x plus 6x. So 10y is equal to 10x. And therefore, if we divide through by 10, we find out that, here's x. We find out that y is equal to x. So let's sketch y equals x on the Cartesian. So the graph y equals x will pass through the origin. So this is the equation of the line y equals x.